Optimization problems. When you do optimization problems, you are trying to find the maximum or the minimum of something. So how do we do this? First, you want to make sure you understand what's being asked, what you have, what you need. Sometimes it's helpful to draw a picture so that you can label it. Introduce notation. Get the quantity that you are trying to maximize alone in terms of one variable. Typically, if you have something with 2 variables or 3 variables, you'll have something that connects the 2 or 3 variables. Take the derivative of the equation and set it equal to 0. Find the extrema. Then, you've solved for something. Go back and look at the original problem. Say, what am I actually looking for? Maybe you solved for x, which was the length of something, but you actually need the volume of something. So you need to go back and plug it in. Or maybe just ask for the dimensions. So then you just need to figure out the dimensions given that one variable. Let's look at an example. Find the point on the parabola y squared equals 2x that is closest to the point 1, 4. Well, the first thing I want to do is draw a picture. So I have the parabola, I have the point over here, I kind of did a dotted line to some generic point on the parabola that looks like it might be kind of short. This point is, I just labeled as xy, because I don't know what the point is yet. The distance between those 2 points, well, distance is the square root of x minus 1 squared plus y minus 4 squared. But square root is kind of a pain in the ass. If we can minimize this equation, it's the same thing as minimizing d, and we don't have the square roots to deal with. So we have x minus 1 squared plus y minus 4 squared. I need to get rid of one of the variables. Well, looking up at the original equation, I see that y squared equals 2x, so x is equal to y squared over 2. So I'm going to plug that in. Before I take the derivative, I'm going to multiply it out and simplify. And now I take the derivative, set equal to 0. I have y cubed minus 8 equals 0, so y equals 2. So I found that y equals 2, x equals 2. I go back and ask myself, what was the original question? Okay, it wants me to find the point. So the answer would be the point that is closest to 1, 4 is 2, 2. Next question. Fifi needs a place to stay. You have 1,200 feet of fencing. What is the maximum area you can close off for Fifi in a rectangular pen? So I have a nice pretty pen with a little Fifi in there. I labeled the width x and the height y. Or, it wouldn't be height, but you know what I mean. One side is x, the other side is y. I know I want to maximize area, and area is x times y. Now it's 2 variables. I need to find something that relates these 2 things. Well, I know that the perimeter is 1,200 feet. So I have 2x plus 2y equals 1,200. Dividing by 2 to make my life a little bit easier. X plus y equals 600. That makes y equal to 600 minus x. Now I plug that back into the area equation and multiply through to make taking the derivative a little bit easier. A prime is 600 minus 2x, set it equal to 0. I get x equals 300. Plugging it back in to figure out what y is also 300, so it's a square. Now, what do they ask me for again? They ask me for maximum area. So I need to figure out what the area is by plugging 300 and 300 into the area equation. So I get 90,000 square feet. Well, it turns out you can use the side of the barn for one side of the pen. Now, what is the maximum area you can close off for Fifi? Well, let's see. Area is still going to be x times y. But this time, you have 2x plus y equals 1,200. I'm going to solve for y. So y is 1,200 minus 2x, and plug that into the equation. Multiply through. Take the derivative, and I get 1,200 minus 4x equals 0. So x is again 300, but this time y is 600. What am I asking for again? Maximum area. Plug that in. I get 300 times 600 equals 180,000. You buy another dog, Rover, and they don't like each other. They need a total area of 1,000 square feet. The outer fence is only $3 a foot, but the middle fence has to be stronger so they can't get at each other, so that's $6 a foot. What are the dimensions of the pen that cost the least to make? Okay, so what do we have? We have important information that's 1,000 square feet, $3 a foot for the cheap stuff, $6 a foot for the expensive stuff. The area of the pen is 1,000, and that equals x times y. Solving for y, I get 1,000 over x. Now I want to figure out the cost. So I have the cheap fences. I've got the 2 x's and the 2 y's. And I have the expensive fence down the middle, which is another x. So my cost, I have 2x plus 2y times 3, the cheap one, and x times 6, the expensive one. Let's simplify that and plug y in So I get 12x plus 6,000 over x when I simplify it. Now I take the derivative, get 12 minus 6,000 over x squared. Set it equal to 0. Solve. I get 12 equals 6,000 over x squared, so x squared equals 500, which makes x equal to plus or minus 10 square root of 5. Minus doesn't make sense. So it's about 22.36. And that makes y approximately 44.72. What am I looking for again? Dimensions. Okay, so the answer is the best dimensions are going to be 22.36 by 44.72. Next problem. A cylindrical can is to be made to hold 1 liter of oil. Find the dimensions that will minimize the cost of the metal to manufacture the can. Well, first off, we want to remind ourselves that 1 liter is equal to 1,000 cubic centimeters. Draw a picture of a cylinder, and let's see, remind ourselves, if I'm going to minimize the cost of the metal to manufacture, that's going to be minimizing the surface area. And I know the volume of this can has to be 1,000 cubic centimeters, so I need both the volume and the surface area of a can. So the volume is pi r squared h, and that has to equal 1,000. The surface area, I have 2 pi r squared, which represents the top and the bottom of the can, and 2 pi r h, which represents the outside of the can. It's 2 pi r is the circumference of the bottom, and h gives you the height. Imagine you take a can, cut down the side, and you open it up, you have a rectangle. So I need to get rid of one of these variables. The h looks like it's the easiest thing that I want to deal with. So I'm going to solve for h. H equals 1,000 over pi r squared. I'll plug that into the surface area equation and simplify it. Now I take the derivative with respect to the radius. Get 4 pi r minus 2,000 over r squared equals 0. Solve for r. I get r is approximately 5.419, which means my height is going to be 1,000 divided by pi r squared, which gives me 10.839. What am I asking for again? The dimensions. So the answer will be radius of 5.4-ish, and the height is 10.8. One of the neat things to notice is when we did the Fifi example and we had the rectangular area, the best we could do was a square. If you look at this, diameter of the can and the height of the can are the same, so we're kind of getting a squarish kind of thing again, which I always thought was kind of cool. Next example, we have a 10 by 10 inch piece of cardboard. We want to cut squares out of the corners to make an open-topped box. What size should we cut to maximize the volume of the box? Let's draw a picture of this. I have my 10 by 10 piece of cardboard. I'm going to cut equal sizes out of the corners so I don't have a lopsided box. Once those are gone, I've got 4 flaps, which I'll fold up and make an open top box. So I need the volume of this thing. Well, the volume is going to be the length times width of the bottom, which is going to be 10 minus the 2x. And the height of the box is x. So the volume of my box will be 10 minus 2x quantity squared times x. I'll take the derivative and get something really gross. Don't multiply it out. You want to factor it. You can pull 10 minus 2x out of both of these terms to give you 10 minus 2x times what's left is a 10 minus 2x, and this crap turns into just minus 4x. Now I can simplify and set equal to 0. Much easier than having to multiply it all out and then try to figure out how to factor it. So setting each of these equal to 0, I know that either 10 minus 2x equals 0 or 10 minus 6x equals 0. Well, that's interesting. We don't usually get two answers. So either x equals 5 or x equals 5/3. Which is the right answer? What makes sense? Well, if x is equal to 5, that's half the box. That means you just cut the box into 4 pieces. So that's going to give you a minimum size box, which means our final answer is x equals 5/3. Actually, is that my x? What's the question again? What size? Good. What size should we cut it? We cut 5/3 by 5/3 is our little square. So doing these examples, find an equation for what you're trying to maximize or minimize. Find it in terms of one variable. Once you've done that, take the derivative, set equal to 0, and solve. Once you've solved for whatever you're solving for, go back and reread the question and say, okay, what am I actually looking for and how do I figure it out given the x that I just solved for? And as with most math things, the more you practice, the easier it gets.